Homework 5.2 is more integration practice with a lot of u substitution in there. Let's see, let's start with number 2, because it's a little bit different than we've had before. Find the area bounded by the curve y equals square root of 4 plus 3x, the x-axis, the y-axis, and the line x equals 7. So it's saying find the area of this guy, the x-axis, the y-axis, and x equals 7. Well, it's basically asking for, whatever this ends up looking like, it's asking for the integral from 0 to 7. That's how we find the area. And we know it goes from 0 to 7 because it goes from the y-axis until the line x equals 7 of the square root of 4 plus 3x. Okay. This is a u substitution one because this would be a chain rule if we were doing a derivative, because the derivative of the inside isn't just 1. So u is 3x plus 4. The derivative is just 3. And so we can rewrite this as the integral of u to the 1/2 power. There is no 3 out here. When we do the chain rule, when we take the derivative, it'll multiply by 3. So we always end up dividing by the du. So it's going to be 1/3 of this integral. And we don't actually need to change back to x's. We can keep it in u's if we change these bounds. So x went from 0 to 7. That means u will go from when x is 0 to when x is 7. When x is 0, u is equal to 3 times 0 plus 4, which is 4. When x is 7, 3 times 7 is 21, plus 4 is 25. So this is the integral of 1/3, the integral from 4 to 25 of 1/3 u to the 1/2. So u to the 3/2 power, we need to divide by 3/2, so it'll be 2/9 u to the 3/2 power from 4 to 25. This is 2/9. This is u, this, I guess, square root of u to the 3rd power from 4 to 25. So it's 2/9 times square root of 25 cubed minus square root of 4 cubed. So this is 125. So 125 minus square root of 4 is 2, cubed is 8. So we get 2/9 of 117. And this actually can divide evenly. You can divide 117 by 9. If you don't know, this is a middle school trick. If the digits add up to 9, you can divide by 9. 1 plus 1 plus 7 is 9. So 9 goes into this 13 times. So 13 times 2 is 26. Okay. Let's do a different one. Let's do this guy, 7. Using the u substitution, x equals 2t plus 1, which is equivalent to the integral from 0 to 3 of the 4th root of 2t plus 1. So x is 2t plus 1, dx is 2. And so what we have here is the integral of the 4th root of x. And we don't have a times 2, so we need to divide by 2. Again, the chain rule, if you do the derivative, will multiply by 2, so we're dividing by 2 here to undo the chain rule. That way when we actually multiply by 2, it'll cancel out, and there won't be a number here. So it's the integral. It was from 0 to 3, but that was for t. T went from 0 to 3. When t is 0, x is 2 times 0 plus 1, which is 1. When t is 3, x is 2 times 3 plus 1, which is 7. So it's 1/2 the integral from 1 to 7 of the 4th root of x. So there we go, d. Okay, I'll do one, well, I'll look at this one. So here we've got tangent squared of theta times secant squared of theta. It's unclear which one is the inside function. Maybe u should be tangent of theta. Or maybe u should be secant of theta, and then, you know, the du will be something. Well, only one of these works, and even though it looks like it could be either one, the only one that works is u is tangent of theta, because if u is tangent of theta, the derivative of tangent is secant squared, which we have. On the other hand, if you said the u was secant of theta, the du would be secant of theta, tangent of theta. Actually, this works really well. There's not a way to make it work. I thought for a second this was going to work out also, but it doesn't work out. We do have a secant, we do have a tangent, but the tangent is squared, and so there's no way to get around that. So this one doesn't work because the du we don't have. Whereas this one, if u is tangent of theta, we have the du right here. So this is what we're going to use for our u substitution. dy dx is tangent of theta squared, so u squared times the du is right there. So when we do the integral, we'll get y equals 1/3 u cubed plus c, and u is tangent of theta, so it's 1/3 tangent cubed of theta plus c. All right, I'll do number 8 also. Second number 8, I'll do both number 8s, I guess. This one is really tricky because the inside function is very clearly this. U equals x minus 1, but the derivative is just 1, which is not here. And that actually stops you from being able to do this u substitution because you can't have something multiplying when you don't have the derivative of the inside right there. But there's another trick you can do, which is that u is x minus 1. We can solve for x. X is, by moving this 1 to the other side, x is u plus 1. And so I'm going to substitute both of these in for u. It's the integral of x is u plus 1 times the square root of u. And this is u plus 1 times u to the 1/2 power. And the trick here is that you can multiply it out. You can distribute it. So you get the integral of u to the 3/2 power plus u to the 1/2 power. And the du is just 1, so the du isn't doing a whole lot. And so you can do this integral using power rule now. So it's kind of a weird trick where the du wasn't multiplying, but you could distribute out the square root of u and be okay with it. All right. I think that's all the ones I'm going to do. You know what? I'll look at one more on the back. Number 9. I really like ones like this. Here, it's never going to be the top one. Well, almost never going to be the top one. Usually the bottom one is the inside function. And the reason the bottom one is the inside function is because if you have 1 over u du, this will be a natural log one. And this is the same as 1 over sine times cosine. And so this is ones like this will often end up with this is the du here. And that is the case here. On the other hand, here, the obvious inside function is natural log of x, because the derivative of, so it's just like u squared times the derivative of natural log of x is 1 over x. So that's what this is. This is natural log of x squared times 1 over x, which is the derivative of natural log of x. I'll let you guys do the rest on your own. I think you should be a good